Hello, I'm Rami. I'm a field service engineer with OSIsoft. Today we're going to be creating a set of videos on high availability and how to implement it at your site. We're going to take a traditional Pi system, one with a Pi server 2012 in this case, that has one OPC interface writing data to it, and we're going to turn it into a Pi server 2012 collective with failover OPC interfaces. Why would you want a highly available system? The traditional Pi system really is reliable, but there are always situations that are planned or unplanned and could trigger data loss or render data inaccessible. This can be planned maintenance such as operating system updates, software or hardware upgrades. It could be unplanned, like a software or hardware failure, some break in the network communication and users can no longer connect to the Pi server. And during those times, the data is completely inaccessible. Having a collective or on the Pi server level will allow the users to access another server that is available, and that switch would be automatically done on the Pi server side. So the user won't even need to know that, for example, the primary Pi server is down. They'll just know that they are still able to see their data, and that's what's most important. From an administrator's perspective, it makes your Pi system more scalable with another server available there. It makes it much easier to perform maintenance on the machines, and if your primary Pi server needs an operating system update, you can shut that down, keeping the secondary up and accessible. And once the primary is back up, you can do the same on the secondary. It also provides an easy option for disaster recovery if you were to house your members of the collective in different locations. And if one was to have a power outage, another one is still available because it's on a different plant. That's one of the main benefits to a high available system, and we're going to go through how to configure one. Now, before I even start to install any new Pi servers, I want to do a health check on the server that's already running on this machine, just to make sure there isn't any major issues that need to be corrected beforehand. Let's take a look. I am on my primary Pi server, and I want to open the Pi System Management Tools. It's a very handy administrative tools application for the Pi server. And let's take a look if there are current values updating first. I know there's an OPC interface sending data. I'm going to search specifically for those tags. Have them start updating. We can see that they're updating every second or so right now, which is the rate at which I have the interface scanning. Let's see if they're storing data in our archive. Again, I'll do a search for our OPC tags. We're getting the last 2 hours of data. Pretty much everything that's updating the snapshot for these tags is being written to the archive. And you can see there is a good amount of stored data here for all of our tags. We know that the data flow is good. Now let's take a look at the message logs. Under Operation, I'll go to Message Logs. I want to look at the last 3 or 4 hours. This is a very new server, just installed, so there isn't much information here yet. If you did have a server that's been around for a while, I'd look even through the last day or two, just to see any major issues or errors that have been posted to the logs. These are all informational. Scroll down. And here's one of our red X marks for an error. Something about the update manager with the Pi totalizer subsystem. And if I look above it, it says that the error cleared, so I'm not very concerned about that. Go down further, and there's a warning about our license expiring. I am using a temporary license. It's going to be expiring in about 10 days, so this is an expected message as well. To take a look back even further. Go back 2 days. If you want to filter by severity, debug will bring up all messages. I can bring up just warnings. I'll bring up warnings and errors. You can see that they're mostly update manager, and I'm sure if we searched, we'd see that those errors cleared. They seem to be pretty infrequent and related to a couple of subsystems that I'm not really using at the moment. And I did replace the license just today, so this confirmation error is an expected message as well that I corrected. Another place I want to look, the snapshot and archive statistics. Here we can see the events being written to the snapshot from the buffer on the interface node, and then from the snapshot what's being written to the archive. We could see if there's any out of order events, any events being skipped. This is where you would come to look. And our left column is the total value since the subsystems were started, and the right column is the change as it happens every 5 seconds. There is a running counter up here under update time. I'll highlight that as the running counter. So we see our archived events, and we have no out of order events since the Pi server was started. The archive record disks reads and writes looks to be good as well and about equal. Let's take a look at snapshot events down here in out of order. It's okay to have a number in the out of order snapshot events. You just hope to see it be relatively small to the total snapshot events being posted. Something along the lines of 1 in 1,000 is an okay number to have. So far we have verified current values and archive values. Check the message logs. Check the snapshot and archive statistics. Now I want to go over to the interface and verify buffering. We did see we're getting data, so I know that buffering is working, but I just want to show you guys to get yourselves a little familiar with it in case you were to run into some errors in data flow. On my interface machine, I want to pull up a command prompt. I'm going to navigate to my PyPC folder with the Pi home environmental variable and then the bin directory. I'm running the PyBuffer subsystem, and the command is pybuffss-qs. It is the Q statistics. Let's pause for a second and zoom in here. Now this column on the left is the total values written since the buffer was started, and the one on the right is a change, similar to what we looked at in the snapshot and the archive statistics. Now here we see total event reads and writes. Ideally we want to see these numbers equal each other. That means that everything being written to the buffer is being read out and the connection to the Pi server is good. If that connection were to be broken, we would see instead that the current queue events would fill up instead of the total event reads. Why don't we simulate that behavior just so you can familiarize yourself with what it looks like. Now I'm stopping the buffer from sending data to Pi. I just wrote a command to break that connection. And if we look, we see that instead of events being read from the buffer, they are starting to queue. That queue will grow until the connection to Pi is reestablished. And if we look on our Pi server, in current values, you can see we've stopped receiving data. Let me resume that connection from the buffer. And and immediately dumped out all the data in the queue. Let's go back, and now the event writes, event reads are equal. Let's go back to the Pi server. Data is updating again. Now that's just to show you if your current values are not updating, you got to make sure that the buffer on the interface node is working properly. During the creation of a collective, the primary server will not be going down, but just in case something were to happen, you know where to look. Let's start installing our secondary Pi server. I'm going to go over to my machine. This is a brand new machine. All it has is a Windows Server 2008 OS at the moment. The first thing I would like to install are the prerequisites we have. Before that, I know that it requires the .NET Framework 3.5.1, and in Windows Server 2008 that needs to be established through a server role. I'll go to my server manager, add roles, and I want to select the application server role. You can see it sets up the .NET Framework feature. It's a very quick setup. Now I can continue with my install kits. I have downloaded the prerequisites standalone package. This does not require any internet access to install some of the kits it wants to install, but there is an online version. The difference is just that the standalone is about 250 megabytes in size, while the online is 20 megabytes, since it's getting most of its data from or through the internet. I'm going to unzip it to a location I can easily go back to in case something were to go wrong with the installation. Now that's done, I also want to set up a recently released patch for the prerequisites. It'll install a newer version of the runtime redistributables. Alright, that's finished. We can now install the Pi server. As we get to each step during this installation, I'll discuss some things you need to know when setting up your collective. For example, how the licensing works, how to connect to an AF server. An AF server is a prerequisite for Pi server 2010 and later, but you can see we're actually not installing an AF server on this machine. That is because we can share the one that is already being used for the primary Pi server. I'll need to create a folder for the Pi server, 64-bit install kit. There's always a warning message saying that a Pi AF server must be available in order to continue. I'll hit OK. Take a quick glance through all the products that'll be installed just with this installation. And at the end, we'll make sure it was all successful. It'll go through those initial prerequisite stuff of the Pi server, and now we get to the Pi SDK. we can choose our destination folder. And since we only have a C drive on this machine, it's going to host all of this installation. Default Pi server is going to be this machine, Walnut, and it'll install. The Pi API will also install for the 64-bit folder. And now we'll begin the actual Pi Server 2012 installation. The first step here is that it needs a license file, specifically a PyLicense.dat. You can see there. It needs a license file of that name. I haven't talked about licensing yet, so here's a good time to pause and go back to our primary Pi server. If you are familiar with licensing and generating license, you will need to go to our tech support website. It is techsupport.osisoft.com. Once there, you'll sign in if you have an account. And if you have an account, you would want to be assigned to the specific site for your company. That is what gives you access to downloads and the ability to generate licenses. Now, you would go to My Support, My License Activations, where you will see hopefully an organization and a site listed. I'm an employee of the company, so I actually don't have anything here. I needed to create a license in a different manner, but I'll continue through the process. Once you select your organization and your site, there will be a link taking you to download a utility, and that utility is called the Machine Signature File Generator utility. It is under the Pi Server product. You can download that. And when you run it, it's going to generate this file, your machine name.msf. That MSF file contains specific information about the hardware being used for the Pi server, and the license will be generated based on it. Once you get it, you upload that file back to us, request for a license to be generated, and you should hear back soon after with a new license. And that license will come in a folder that looks like this, especially if you are licensed for a collective. You'll have your manifest, a simple README file, a PyLicense.dat file, and a temporary license.dat file. The PyLicense.dat file is the file generated specifically for your primary Pi server, which is the server that the machine signature file came from. So this machine that's already running has this PyLicense.dat file. The temporary license.dat file will be used when installing any new secondary nodes for your collective. So since we are installing a secondary node right now, I'm going to copy this file over to my secondary Pi server machine. I copied it, but I did mention that the installation is looking for a file with the specific name PyLicense.dat. So I'll change that here. And let's go back over to our secondary. Under License Activation File folder, I'm going to browse to Pi Install Kits. You can see here it looks for a PyLicense.dat file, and it says it exists in this folder. We can hit OK and continue with the install. I also mentioned that we're using the AF server that is being used by the primary. Once the connection is successful, we can continue. I am not going to enable the Pi module database. The key thing to note is that when the collective is created, it is cloning all the configuration for the primary server over to the secondary nodes. So it's really just an extra hassle and step to enable the module database during the installation of the secondary. This is an important step though, because this information is actually not copied over and is specific to each Pi server. The Pi server binaries, where would you want that located? I mentioned before that if you have other drives available, we would prefer to have it installed there, for example, a D drive. And your event queues and archives we'd also like to be on a separate drive. But since in this case we just have C, I'll leave the Pi server binaries as is, and I just want to change the folder in which the event queues and the archives will exist. I do not want it to be the DAT folder. I'll just create a new one called queues for event queues, and a new one called arc for the archives. Let's take a look at the settings. We now automatically enable auto archiving with the installation of Pi Server 2012. So here's a selection. Yes, we do want automatic archiving. If you did not, you would select no. It'll add the name of your Pi server as a prefix for the auto archive names. This is an example. It'll have it prefixed to the time that the archive started. And we also have a default archive size of 512 megabytes. You can change that as you wish. I'll leave it as is for now. Once you click next, it'll go through the entire installation of the Pi server. The installation is now complete. You can verify that and scroll through. Everything looks installed. Now to officially complete the installation, I want to start the Pi server from the batch script. I'll access it through our environmental variable, and the batch script is pisrvstart. This will complete some of the run once functions that a Pi server needs in order to complete the installation and set it up for the first time. We have current mode open. Now we know it's started. Let's perform some of the same health checks that we just did on our primary Pi server, just to make sure that everything looks good and we'll be ready to create the collective. Next, let's look at current values. I know we have no interfaces sending data right now, but on any new installation of the Pi server, we have the default tags installed, so I can take a look at those. We do have current values. We may need to wait a little bit just to make sure we have current data. We may have missed an update. Once we've verified that the tags can update, we'll go and check that they're being archived as well. Here we go. I saw a few start to update. Let's take a look at archive values. We have at least one archive value for the active tag here. And we see that it's working. If I take a look at the message logs, I don't need to look more than the last 5 minutes since that's the first time it was started. I just want to see if there are any critical errors. Here are a couple that are related to the Pi MDB to AF preparation wizard. This is a step that we skipped because we did not enable the MDB, so it's an expected error. Otherwise, everything looks good. Snapshot and archive statistics. We're seeing archived events, that value is changing. Record disk reads and writes. Snapshot events, nothing out of order. We look like we're clear and are soon to be ready to create the collective. Now, in order to create the collective, I need to first connect to the primary. And come back here and take some of these notes down. Now installed a secondary Pi server and verified its health. To create the collective, we need to ensure connection between the servers. Let's go set that up. I want to connect to the secondary, or to Walnut, from our primary, which is called Chestnut, which means I need a trust created. Let's go here and go to Advanced. I'm going to title the trust Chestnut and just make it for the fully qualified domain name. I'll give it full user access. If I go to Chestnut and go try to add a server and connections, it's successful and it has taken our trust as Pi admin. If you remember before, I said that during the collective it's going to copy all of the configuration changes from the primary and clone it onto the secondary. That includes all security configurations, and you might be thinking, well, we just created a trust on the secondary, isn't that going to be overwritten? You're 100% right. So what I want to do is create that trust on the primary as well, just anticipating that we're going to need the connection between the collectives. So I'll create one for Walnut. And one for Chestnut. We have those created in anticipation, and at this point we can start creating our collective. Now we're ready to configure it. And we're going to do so through the Pi Collective Manager. It is an application installed with the Pi server. We don't have any collectives created yet, so I'll right-click here and create collective. Have you verified your backups are valid? In my case, this is a very new Pi server with no data, or hardly any data, so I'm not going to go in and back it up right now. But if you have a server that has been running for 3, 4, 5 years and has that much data associated, I suggest that you run a backup immediately prior to creating a collective. Have you verified that your Pi interface server's configuration is correct? Let's go over to our interface to show you what we're talking about. And this has to do with the Pi buffer subsystem. If we go into Pi interface configuration utility, or Pi ICU, and select our interface, see it's running, but let's go and check tools buffering. We have the Pi buffer subsystem enabled. If we select buffered servers, there is our Chestnut Pi server selected. It's what's being buffered to. If you look here, there is a replicate data to all collective member nodes box that is grayed out right now since this is just a single Pi server. And you can see listed is any Pi server with a checkbox next to it. What Pi Buffer subsystem will do, as soon as the collective is created and established, it'll recognize, as long as the collective has the same name as the primary Pi server, that another member has been added to the collective, and it'll automatically add it here for data to be buffered to. This is what it's referring to when it says to verify that your interface server configuration is valid. Now we're ready to continue creating the collective. I have an existing Pi server that does contain historical data. I want my primary to be Chestnut. Notice that it automatically gave the collective name the name of the primary. That is the default. If you do not want that, I'll show you where you can change it later. But it's recommended because of the effect on buffering. I want my secondary servers to be Walnut. I've added it here. This is any archive that is going to be copied over and cloned. If you had 5 years worth, this process could take a while, so keep in mind that it won't always be quick like mine will be. Backup will be created during the collective creation as a rollback, just in case something goes wrong during the creation of the collective. Here is the summary setting. Collective name, primary server, and secondary server. If you go to advanced options, this is where you'll be able to change the name of the collective if you wanted it to be something other than that of the primary. I want to leave it as is. And once I click next, it'll begin. At this point, what you need to make sure of is that the connection and the sharing between the machines is open. So what the primary is about to do is stop the services on the secondary. So it needs access to do that. That access is established when the remote registry service is turned on and started. If you look here, the remote registry service. Without that started, the creation of the collective will fail. It also needs access through file sharing in order to copy the archives over into the proper directories, as well as all the configuration files. This is something maybe you will need to check with IT that it is properly configured. I'll click next and it'll start the process. At this point, you can see it has stopped the services on the secondary, made a backup for rollback purposes, copied all the files over to our secondary machine, and it is now starting the server. Once that's done, our Chestnut collective was successfully created. I'll click Finish. We see it listed in our collective manager. If we highlight it, we want to see 2 green check marks, or a green check mark by any member of the collective. If we maximize this, let's take a look at some of the attributes and properties. There is a COM period and a sync period. The COM period is 5 seconds, and that's essentially a ping just to check that it can communicate with the server. The sync period is how often it actually synchronizes and replicates data, just to ensure that the configurations between the servers are identical. If there were any errors, they would be listed under COM or sync status, and if it was a sync status failure, there would be a reason as to why, and probably an error code that if you were to call tech support about the issue, they will ask you for. We'll come back and I'll show you what it looks like if there is some kind of break in the collective. For now, I want to close Pi System Management Tools and reopen in order to refresh the cache on our Pi SDK. If you look here, we now have a collective chestnut with our server as the primary and walnut as the secondary. I'll connect to both. Let's view current values. We can look at all tags first. We now have 2 of each tag, one on the primary server and one on the secondary server. The OPC are all updating, you could tell. And that is because the buffer has taken the change and is now buffering to each member of the collective. I want to exhibit some of the replication capabilities of the collective. Let's create a new point. I went to Point Builder. I'm going to create a point by the name of test create and save it. The point is not created until it is saved. We see it listed here just under chestnut. However, if I go to tag search, perform a search for that tag, there are 2. It has already synced and created one onto the secondary. Right there, walnut. Another configuration that is replicated are any mappings or trusts. Let me create a mapping for my user that I'm logged in as. It is the Pi School Administrator. I'm going to give it Pi Admin access. If I hit OK, it's now created. Let's refresh. It is synced over. There are some things that are not replicated. Specifically, the tuning parameters. It's under the Operation tab. These are parameters specific to each Pi server, and it is unique for every server. It determines how it's going to run. Sometimes there's some back-end changes that may need to be made in case your Pi server were to be experiencing problems. But let's look, and we could even show there's parameters for chestnut and parameters for walnut. In this case, they're pretty much the same because they're fresh installations, but let me show you what it would do. Let me change the AutoArchiveFileRoot. That is the prefix of our new archives that are created. I'm just going to add a test to the end of chestnut. Hit apply. That's changed. Let's look at what it is on walnut. It took chestnut because that is what happened during the clone of the collective. I'm refreshing, but it's not changing. So you can see that these do not sync. In fact, I would even change this right now to walnut, because the archives are going to be created separately on each machine. You never know if they're always going to be at the same times. Let's go check buffering. I'll show you what that looks like now that the collective has been created. Back on PyICU, Tools, Buffering. I'll go to my buffered servers, and now we have available the replicate data to all collective member nodes. If for some reason you did not want to do that, you can uncheck that. And we have our walnut.pyschool.int server added to the collective as a secondary. I had the queue statistics as running the whole time. I can stop that, and now if I run it, it'll give me an option to view which session I want. Let's look at the one for walnut, our secondary. There's less total event reads and writes because it has just been established, but it's running properly. I want to show you what it looks like when the collective is broken. So let's stop the secondary server and go over to Walnut. And to stop it, I want to run a similar script as I did to start it, just with stop instead, and let that run. All the Pi services have been stopped. Let's take a look at Collective Manager. It is already having a red X by it. It is not available, we could see here. It can still communicate with the machine, but it just cannot communicate with the Pi server. However, if we go back to SMT, we still have access to data. This would be the same if the primary server went down and you had to connect to the secondary instead. So if I bring back up my secondary server, now that it's back up, in Collective Manager, all looks good. So at this point, we have successfully created a Pi Server 2012 collective and validated replication across all members of the Pi collective. Next, we're going to create a highly available interface level failover. So I hope to see you there.